Okay, in this presentation we are going to look at complex numbers, and it's a question that's broken up into three parts, and each part is simple enough. So the first question asks us to find the complex conjugate of the following three numbers, complex numbers. Now usually what you do, to just sort of be wary of the fact I'm about to deliberately walk into a mistake, is that what you usually do is pick out the sign in the middle, okay, and you just change the sign. So that would become A minus BI, okay. So essentially, that supposes you change a sign that goes here, okay. Now, but watch what I did there. In this particular instance, I actually put the imaginary part first, okay. So if you were to write out 3i minus 2, that would be wrong, okay, because I actually have it back to front. So actually, in this case, what the complex conjugate should be is minus 3, just leaving it in the form that it's in, minus 3 plus 2, or you could put the plus 2 at the start, so you have plus 2 minus 3, okay. Typically, the complex conjugate is written as just a cap over a bar over z, okay. So in this case, it's straightforward enough. In the second case, it's 1 minus 8i, and in the third case, 0 is a and bi is 3i. So this is, I'll just write it out in long form for this particular case. Not that it's wrong. Sorry, that should be a minus there. Apologies there. Okay. So those are our three answers there. Okay. And again, be very careful about that. It supposes that the imaginary part is second and that the real part is first. But that might not always be the case. Okay. So that's grand. So the second part is basically what we're going to do is a division of complex numbers. So my pen slipped there for a second in case you're noticing a blip, and essentially what I did is I'm just starting after pausing there for a second. What I did though here is re-expressed Z, but what I'm doing here is multiplying it by the complex conjugate of the denominator, so the complex conjugate of that, above and below the fraction line is this complex conjugate. So essentially what I'm doing is multiplying my original expression there by 1, but I've broken it up, so I'm multiplying it by the complex conjugate above and below the line, which will amount to 1. Okay, so what I'm going to do first off is look at how we can re-express the denominator. Okay, so essentially it's a number times its complex conjugate, so it's minus 4 squared plus 3 squared, and that actually will work out to be 16 plus 9. That will actually work out to be 25. Okay, so multiplying out the numerator, we'll start here by concentrating on minus 1 and multiplying through the other expression. So minus 1 times minus 4 gives us plus 4. Minus 1 times minus 3i gives us plus 3i. Then now we look at minus 2i. So minus 2i times minus 4 gives us plus 8i squared. Okay. And minus 2, so it's plus 8, sorry. And then finally, minus 2i minus 3i will give us plus 6i squared. I'm getting a bit carried away. Okay, so what we'll do here is re-express this here as that's going to become minus 6. So essentially what we end up with is 4 minus 6 gives us minus 2. 3i plus 8i gives us 11i. And again, our denominator is 25. So that is the answer we're looking for. So finally, another complex. This is actually a little bit simpler, really, than the last one. It's very straightforward, but it just looks a little bit unusual, really. But essentially, all we're doing is the same thing, really. Which is essentially the trick to this, really, is treat the numerator as a complex number. So again, z equals I over 1. Sorry, 1 over 1 plus I times, it's the complex conjugate of the denominator. There we go. 1 minus I. Now, 1 plus I and 1 minus I, that essentially works out to be 2. Yeah, so over 2. So 1 times 1 minus I just gives us 1 minus I. So, yeah, that's it. So, yeah, just the... There we go. That's out of shot a little bit. So that is what the answer we're looking for. Okay, we'll leave it there.